All right, so on 3-4 and 3-5, this is going to make up the bulk of what you have to know for factoring. You have to know to factor a trinomial. Okay, a trinomial means you have 3 terms. All right, so we're going to start a little bit differently than most teachers do. I'm going to start when the leading coefficient is not a 1. It's greater than 1. Okay, so the leading coefficient, first and foremost, the leading coefficient is the coefficient of the term with the highest exponent. So in a quadratic where the highest exponent is a 2, its coefficient is the leading coefficient. Okay, so step 1 to factor is factor out any of the GCFs. Now sometimes this means factor out a negative sign. Your leading coefficient needs to be positive. You're going to multiply the leading coefficient by the constant, list all the factor pairs of the product from step 2, figure out which pair adds to be the B term, split the B term into the factor pairs, and factor by grouping. So let me show you what this looks like. Okay, first and foremost, all 4 of these examples, both the A or the B and the C are all positive, so there's nothing negative here. So on example 1, I would check for GCF. Okay, there's not one. Then I would take the leading coefficient and multiply it by the constant. And make sure you include the sign in front of it. So 2 times 3, which is 6. Then list all the factor pairs of 6. So these are pairs of numbers that multiply together to be 6. So that'd be 1 and 6, and 2 and 3. Then you're going to figure out which pair adds together to be positive 5. In that case, this is the 2 and the 3. Okay, so I have done step 1 where I factored out any GCFs. I didn't have one. Step 2, multiply leading coefficient by the constant. That was the 2 times 3. Step 3, list all factor pairs. I did that. That's the 1 and the 6 and the 2 and the 3. Step 4, figure out which pair adds to be the B term. I've done that. It's 2 and 3. So step 5 is split the B term into the factor pairs. Here's what that means. I'm going to take 5x. I'm going to break it up into a 2x positive and a 3x. All right, I am uncombining that 5x. I'm decomposing it. Okay? This is still technically a 5x. It's just broken up into parts as opposed to a whole. You bring down the plus 3 and the 2x squared. Now we're into 4, factor by grouping. First 2 terms and last 2 terms. GCF of the first group, GCF of the second group. Common binomial factor, and then whatever is left. Okay, now remember guys, we are undistributing. All right, this, let me get my highlighter. These 2 factor pairs are equivalent to this standard form. They represent the same function, just different versions of the same function. If I were to redistribute this out, I would get 2x squared plus 3x plus 5x, or 2x plus 3, and I would get 2x squared plus 5x plus 3. These 2 are one and the same function. There's no difference between the 2 of them. Okay, if I were to graph them, they'd be the same parabola. Okay, look for GCFs. You do not have any on number 2, so we're going to multiply the leading coefficient 2 by the constant 7. So factor pairs of 7. And I need a pair that adds together to be, just lost my train of thought, to be 15. Okay, so that's going to be 1 and 14. And break it up, positive 1n, positive 14n. Bring down your plus 7 and your 2n squared. Okay, now, group the first two terms and the last two terms. GCF of the first group, GCF of the second group. Common binomial, and then whatever is left. Okay, now remember guys, 1n, let's use a different one. 1n and 14n, if I add these back together, I get 15. These are the same function. It's rearranged, but it's the same function. Okay, 2n squared plus 15n plus 7 is equal to, they are equivalent to its factors. Remember, if you redistribute out, you're going to get this. All right, 3x squared plus 20x plus 25. Let's see, no GCF, multiply leading coefficient by the constant, that's 3 and 25. So factor pairs would be 1 and 75, 3 and 25, 5 and 15, that may be it. 9, no, 10, 11, 12. Nope, I think that's it. All right. So I need a factor pair that adds together to be 20. That's going to be my 5 and 15. Take that 20x and we break it up. Positive 5x, positive 15x. Bring down that plus 25 and that 3x squared. Group, first two terms and last two terms. GCF of the first group. If you do this right, guys, you will always be able to factor out a variable from that first group. Sometimes a number, but always a variable. In this case, an x. Put a plus sign here because I have a plus sign there. GCF of that second group is 5. Common binomial. And then whatever is left. All right, no GCF here. Multiply leading coefficient by constant. 5 times 2. Let's see, it's going to be 1 and 10, 2 and 5. Find the factor pair that adds together to be 7. It's going to be 2 and 5. Bringing down the other terms. Group the first two terms and last two terms. GCF of the first group. Now, second group, I kind of want you to highlight this. Okay, here's why. Your second group does not have a GCF other than a 1. You can always factor out a 1 or a negative 1. In this case, because that's positive, I'm going to factor out a positive 1. It's going to keep the factors the same, but it's going to give me a value right here. That common binomial factor is now 5x plus 2. And here's why I needed that 1. It's your other binomial factor.